universe. The universe remains beyond human comprehension, yet that does not stop us from endlessly exploring it. From the dawn of time until now, humanity has ceaselessly observed, measured, and studied the universe, hoping one day to fully comprehend all its mysteries. We have made significant progress, but the universe does not allow humans to become complacent too soon. Because it never ceases to bring surprises and new challenges, pushing the boundaries of human imagination. So what is the universe, truly? The longing to explore the cosmos arose very early in human history. Scientists have discovered stone slabs dating back to around 3000 BC, belonging to the Babylonian civilization. When observing the varying lengths of all the days throughout the year, the Chinese also preserved records of solar eclipses dating back to around 2000 BC. Across the world, traces of prehistoric structures remain, displaying strange alignments with astronomical phenomena. Among them, the Newgrange tomb in Ireland is the oldest, dating back up to 5,200 years. At the dawn of the winter solstice, the shortest day of the year, the sunlight will seep through the corridor, illuminating even the innermost chambers. On Easter Island in the Pacific Ocean, there are 7 mysterious stone statues among the hundreds on the island that face the setting sun on the equinox, the time of year when day and night are of equal length. Some suggest that Cambodia's famous Angkor Wat temple was designed to align with the summer solstice. The sun will rise directly in line with the main eastern gate of the temple. The Egyptian pyramids were also built in alignment with the stars in the sky. Although these structures were not used for astronomical research in the strict sense, but they are proof that the builders of this structure were deeply knowledgeable about the orbits of the sun and the stars. We can affirm that the ancient Egyptians knew early on how to apply astronomical observations to create a calendar. The phases of the moon represent its monthly cycle. The sun's movement across the sky helps determine the length of a day and a year. Throughout the year, the sun rises and sets at different positions along the horizon. Stonehenge, the mysterious stone circle, is renowned for its precise alignment of the stones with the sun. On the summer solstice, the sun rises directly over a rock located on the outskirts called Hellstone, also known as Heelstone. Initially, many people believed that Stonehenge was a temple dedicated to the sun god. However, some researchers noticed that these rocks also align with the moon. From this, it is speculated that this place may have once been a prehistoric observatory, primarily used to predict solar and lunar eclipses. Cosmos. Cosmology is a branch of astronomy dedicated to studying and answering the most fundamental questions about the origin, structure, and workings of the universe. What is the universe? Through research, we can understand how it operates, its origins, and how it will eventually end. Cosmology only officially became a scientific discipline in 1916, when Albert Einstein published his theory of general relativity. Previously, astronomers did not have a sufficiently robust mathematical theoretical framework to describe the motion of the entire universe. Thus, cosmology before the 20th century appeared to be nothing more than a chaotic jumble of speculation and religiously tinged intuition. Particularly, ancient cosmology was often deeply influenced by religion and based on spiritual hypotheses. Heaven is a distant place, hidden at the highest point of the sky, beyond the reach of the vast expanse. The ancient Egyptians studied the universe based on the reproductive cycle of the scarab beetle. They believe that the 5 sky goddesses Nut gave birth to the sun god Ra. Altitude is the process by which the god Nut shifts the sun. They believe the sun is reborn each year on the winter solstice, then returns to the body of the god Nut through her mouth on the spring equinox. Thus, the god Ra was endlessly reborn, transforming the universe into a self-sustaining and eternally enduring entity. Ancient civilizations created many stories inspired by the shimmering constellations in the night sky. They imagined lines connecting the stars, forming familiar shapes from life or figures from legends. In Mesopotamia, archaeologists have uncovered stone stels and clay tablets dating back to around 1300 BC, which depict various constellations in detail. Here are the natural English translations for the given Vietnamese text. These zodiac constellations hold special significance because they lie along the sun's path, later documented by the Greeks. For example, the Assyrian, Hieretman, and Squello constellations were later known as Aries and Pisces. Watfist and Grythrans were later renamed Capricorn and Gemini. In ancient Greece, there were traveling troops that wandered through villages, telling mythical stories about the stars in exchange for food and shelter. Contemporary philosophers also craft their own narratives to explain the nature of the universe. One of the earliest dynasties was the Thylas in the 6th century BCE. He proposed the idea that the universe was submerged in water and the Earth floated suspended within that space. Waves in space create earthquakes, while gentler currents make the stars drift. The Greek astronomer Claudius Ptolemy, who lived in the 1st century, compiled a list of 48 constellations. But if we just stay still in Greece, we won't be able to observe the entire sky. The skies around Antarctica were only first recorded in the 16th and 17th centuries, when brave astronomers left Europe to explore and complete the star map of the southern sky. It has also been proposed to add new constellations to fill the gaps in Ptolemy's classical astronomical map. This inevitably leads to debates among astronomers with opposing viewpoints. In England, Edmund Halley proposed introducing a new constellation named Robur Carolinum, named after a type of tree where King Charles II hid from the Royalists after the Battle of Worcester. Although the king was extremely eager for that honor, some of Halley's colleagues showed little interest and quietly brush away the distant stars from your map. It wasn't until 1922 that a solid foundation for this issue could be established, when the International Astronomical Union officially recognized 88 constellations along with their clear boundaries. It primarily relies on maps drawn by the Greeks. Today, we still apply many other findings from ancient Greek astronomy, not just this particular work. Back in those days, there was a man unlike others, one who neither crafted stories nor speculated about the stars. He realized that to understand the stars, the first thing to do was to measure them. He is Hypatros, the one who proposed the star classification system we still use today. When gazing at the night sky, even an ordinary person can easily notice that some stars shine much brighter than others. Over 2,000 years ago, Hypatros meticulously compiled a detailed catalog of 850 stars. Record the precise positions and classify the brightness levels of the stars. He didn't have a specific tool to measure brightness but only estimated it with the naked eye. He arranged the stars in order, starting with the brightest star of first magnitude. The faintest stars have a magnitude of 6. It's astonishing that even to this day, astronomers still use this seemingly simple brightness measurement system. Although modern measuring devices have expanded Hypatros' original 6-level scale, topping the rankings are the brightest stars, with apparent magnitudes bearing negative values. At the bottom of the ranking are stars that can only be observed with a telescope, usually far brighter than magnitude 6. From the ground, the most advanced telescopes can observe stars with brightness levels ranging from magnitude 24 to magnitude 27. But once in orbit, where it is unaffected by the distorting effects of Earth's atmosphere, the Hubbard Space Telescope can observe stars with brightness up to magnitude 30. Each magnitude is typically about 2.5 times brighter than the preceding magnitude. Therefore, a star with a magnitude of 30 would be about 3.5 billion times dimmer than the threshold of visibility to the naked eye. But when measuring visible brightness, we often overlook an important fact. The brightness of an object depends on the distance between it and the observer, as well as the actual amount of light it emits. Therefore, a faint star nearby may appear brighter than a brilliant star that is very far away. This phenomenon follows the inverse square law. This means that when the distance doubles, the light intensity must be halved. When the distance increases threefold, the light intensity must decrease 9 times. To align with this characteristic, the measured brightness, not adjusted for distance, is referred to as apparent brightness. Absolute brightness is the brightness of an object after being adjusted for distance. The red star accompanying Zeus has an apparent magnitude of 0.58, but its absolute magnitude reaches as high as -5.14. That is truly a very bright star, but it lies quite far from Earth. Conversely, because it is so close to Earth, the Sun has an extremely high apparent brightness, reaching -26.7, making it the brightest celestial object in the sky. However, after adjusting for distance, its absolute brightness drops to just 4.8. In other words, although our Sun is brilliant and vital for sustaining life on Earth, it is essentially just an average brightness star in the universe. Ancient astronomers observed and meticulously recorded, leaving us a vast treasure of knowledge about the stars. However, the true nature of those 5 special stars still eluded their understanding. They call them cope-blenist, which means the wanderers, because they drift lazily across the night sky, night after night, unlike the stars that stay fixed in place. The Copernican planets are the 5 closest planets to Earth that can be observed with the naked eye, including Mercury, Venus, Mars, Jupiter, and Saturn. The Greeks of that time did not yet know they were planets, so they imagined them as gods or divine messengers, beings with the power to alter the fate of all living creatures on Earth. Among these wandering planets are Mercury and Venus, whose orbits lie between Earth and the Sun. Therefore, when viewed from Earth, these 2 planets always appear close to the Sun and can only be observed at dawn or dusk. After sunset, Jupiter and Saturn, planets with orbits farther from the Sun than Earth, often appear and move slowly across the night sky. Ancient astronomers could easily observe the motion of wandering planets to predict their future positions. They value these predictions because they believe that as the planets move closer to each other, their influences will overlap and become more powerful. Therefore, planetary conjunctions are also considered significant events that need to be predicted in astrology. At the dawn of science, most people believed that the movement of the stars in the sky would forever remain an unsolvable mystery. Because it is the will of God, and the feeble wisdom of man cannot fathom his supreme will. This perspective began to change in the early 17th century when Johannes Kepler discovered 3 mathematical laws describing the motion of planets in the sky. This shows that we can not only measure, but also comprehend the universe. At the same time in Italy, Galileo Galilei also made discoveries that further ignited humanity's passion for exploring the vast universe. In 1609, he used a telescope to observe the faint, ethereal band of light stretching across the night sky, what people call the Milky Way. Thanks to his telescope, which was still rudimentary and small by modern standards, Galileo discovered that the Milky Way is made up of countless faint, shimmering stars. This is a monumental invention for humanity, as before this, people had always believed that the universe consisted only of things observable with the naked eye. However, Galileo proved that there are things far beyond ordinary observation. That awareness ignited a passion that has endured for centuries, persisting to the present day. Over time, each generation of astronomers has built ever larger telescopes, enabling the observation of increasingly faint objects with greater clarity. Earth's largest optical telescope has a diameter of up to 10 meters, 500 times larger than Galileo. Today, we know that the Sun is merely a small star in the vast Milky Way galaxy. Here contains at least 100 billion stars arranged in a spiral pattern within a flat disk, orbiting around a bulging central region, where even more stars are densely concentrated. From Earth's position within a spiral arm of the galaxy, we see the Milky Way as a shimmering, misty band, which is actually a vast collection of countless stars. The center of the Milky Way lies to the south, in the constellation Sagittarius. If you stand in a very dark place in the southern hemisphere and look up, you can see the Milky Way glowing brightly like a vast cloud, densely packed with shining stars in the galactic core, where the central bulge of the disk swells. The Milky Way's disk has an estimated thickness of about 1,000 light-years, where 1 light-year is the distance light travels in 1 year. According to actual measurements, light travels in a vacuum at a speed of approximately 300,000 kilometers per second. Therefore, in 1 year, light travels a distance of approximately 9.5 trillion kilometers. This distance is called a light year. When using this unit of measurement, we can more easily handle enormous numbers. In the disk plane of the Milky Way, the average star density is roughly 1 star per 4 light-years. However, in the central region of the galaxy, about 25,000 to 30,000 light-years away from the Sun, the densely packed stars form an elongated bulge with a diameter of approximately 27,000 light-years and a height of roughly 10,000 light-years. Neighboring. Most of our neighboring stars are smaller and dimmer than the Sun. Red dwarfs, also known as red dwarf stars, are the most common type of star in the universe. Among these, only 2 stars are comparable in size to the Sun, and the only one larger is Procyon. This star is a Carnes Mano type, with an estimated diameter twice that and a mass double that of the Sun. Near the central bulge of the Milky Way, the density of stars is 500 times greater than in the region where we live. If the solar system were suddenly placed in the center of the Milky Way, it would have many more neighboring stars and accompanying planetary systems. Only about 1/10,000th the distance from Pluto to the Sun. In reality, the nearest star to the solar system is still 5,000 times farther away than the distance from the Sun to Pluto. At the very center of the galaxy, astronomers have discovered matter so densely packed that it forms a black hole. The universe is like that, but our Milky Way is just a small part of it. Overall, it appears as just a tiny island in the vast ocean. There are countless other islands surrounding it. Each of those cosmic islands is a unique galaxy, home to millions or even trillions of shimmering stars. Galaxies typically exist in 3 main forms: spiral, barred spiral, and elliptical. The spiral galaxy possesses a unique beauty, with its striking spiral arms embracing brilliant young stars. Surrounding the central bulge are ancient stars that have existed for ages. A barred spiral galaxy is a type of galaxy similar to our Milky Way. Like a spiral galaxy, but with a central bulge and spiral arms accompanied by a dense band of stars. Elliptical galaxies have a completely distinct shape. They can be significantly larger than the other 2 types and take on diverse shapes, ranging from slender like a cigar to perfectly round like a sphere. Additionally, there exist galaxies with peculiar, irregular shapes that do not follow any specific pattern, classified as irregular galaxies. Some of these galaxies may have once been spirals, while the rest were truly chaotic galaxies. Spiral galaxies and barred spiral galaxies account for about 3/4 of the largest and brightest galaxies in the universe. Additionally, the universe is home to countless small elliptical and irregular galaxies scattered everywhere, commonly referred to collectively as dwarf galaxies. If we consider the total number of small galaxies, the ratio will differ significantly because small spiral galaxies are extremely rare. While many galaxies exist in isolation, others collide and merge into clusters bound together by gravity. This interaction forms galaxy clusters with a count not exceeding 50, commonly referred to simply as a group. Our Milky Way is a member of the local group. This group also includes another large spiral galaxy named Andromeda along with about 30 smaller galaxies. Galaxy cluster. The closest galaxy cluster to the local group is the Virgo cluster, containing approximately 1,300 member galaxies. The Coma cluster has over 1,000 members, while the Hercules cluster has about 100 members. Many galaxy clusters come together to form larger structures, known as superclusters. Cosmic web. They cover vast regions of space that are nearly devoid of galaxies. If those voids are considered space objects, then they are the largest objects in the universe. To better visualize the distribution of galaxies, imagine soap bubbles in a bathtub. The galaxies are scattered across a thin, soap bubble-like membrane, surrounding vast empty voids.